Okay, second video for the electronics college level. We talk about nonlinear component. The nonlinear component, the first simple one is a diode. The diode, you have voltage and the current. This relationship will look like the forward current and the backward current. Now, some point the reverse voltage break down diode. So once it's break down, it's not recoverable. The diode is dead. So make sure you don't apply the beyond this voltage. Now, of course, when V is 0, it should be 0. Then go up. So we approximate this with the exponential function. So the current is going to be I0, which is this current, exponent QV over KT. And if you define this voltage Vt is KT over Q. K is a Boltzmann constant, Q is electron charge, and T is a temperature. Then it's going to be I0 exp V over Vt. And the Vt is about 26 millivolt. So if V is 260 millivolt, it's going to be exponential 10. So the current increases exponentially. But this I0 is very small. And in the real world, if V is 0, it should be 0. But this is an approximate model by exponential function for the diode. Okay. So next one is transistor. Now transistor, this is NPN transistor. PNP look like this. Okay, and both way we apply the voltage collector to emitter voltage VCE, and the current is IC. Okay, so what the transistor does is basically there's not many good book to let you understand what transistor function is. This is the best way, from my experience, to explain. Basically, it's a base connected to the diode, okay? And this diode is connected to another diode, and this is IC. And of course, this control this current diode. So what's happened is, when you have a IB base current, right? And when I apply IC, basically it's behave like diode. IC and VCE behave like diode. However, this diode, the second diode, is controlled by this guy. And how it's controlled? This go up to certain level, then it saturates. And this saturation current is IC, and this IC is roughly beta IB. That means whatever the current you inject, beta is amplification factor. The roughly, if beta is 90 times I see the current flow here. Okay, so 90 times larger current is controlled by this little IB, and this side characteristic look like a diode. This look like a diode up to a certain point, and here it's saturated, and this saturation current is important. This is beta IB. Okay, so depend on different IB, is saturated at different level. So this is a transistor characteristic. So for example, if you have a resistor here, and here's a VBE, you control this. So this is a VCE. So current is controlled. So what's happened is this circuit is analyzed by this load line. Means if IB is 0, then this is maximum E, and no current flow. Okay, when IB increase this way, then this voltage drop because this current is IC, and RIC cause voltage drop. So it's going to be E minus RIC. So basically, if you draw this current, it's this move between this, and what's happened here, when it's reached to this voltage, then it's going to, this voltage goes down further and the current is reduced. Okay, so if you push more IB, then it start dropping here. This voltage is gonna shrink with more current. Okay, so it's move like that. Okay, so this is the characteristic of transistor. This is non-linear. So remember this equation, the IC equals I0. This is the dark current, exponential base voltage VT, and the base voltage is, this is a transistor here, the voltage and IB, there is a relationship, right? Okay, so the transistor's basic equation, you have to remember this. IC exponentially increase by VBE, and VBE is like voltage across the diode. So this depends on current. The current determine VB. So that's why bipolar transistor is known as the current driven. IB determine how much current you can draw. into the transistor. Okay, so it's a current driven element. Okay, now we talk about MOS. MOS device is different. We have a gate, source, drain. So MOS device, how it's made is this is a P region and N region, and the gate. The gate apply and control this the region that connected. So what's happened is drain, source, you can increase or decrease the current going through from drain to source. So that's the ID. Okay, and now I want to just import some well-written equation. Okay, so the saturation line, just like bipolar, this saturation line, the red line, is defined by VDS. This is VDS, right? And this actually this line is defined by this equation. So before it's such before it's saturated here, this red line is defined by this quadratic equation. This is square. So in the MOS bipolar, it was exponential. This line was exponential line. The MOS, it's going to be square. This gate to source, and it's exceed a certain threshold, the square is going to determine this line. Okay, so remember we talk about bipolar exponential line, and it's saturated here. This instead of exponential equation in the MOS, it's going to be square, and it has a certain threshold, and depend on the doping level, you can change the threshold. Okay, and here this is some constant, depend on the silicon materials and others, and the WL. And this WL is, if you look at this from top, MOS channel is made this way, drain and the source, and it has a gate is over. Okay, and this is a length, and this is a width. So you can control this line by different geometry, right? And before it's saturate, this equation is this. Of course, you can tell equation quadratic equation is like this, and you take up to here. From here, it's controlled by VGS, gate voltage. Okay, gate voltage. So MOS transistor is voltage driven because you don't need to inject current into the gate at all. The gate is insulated, so there's no current flowing in. It just feel the effect. You applied VGS, and this voltage is control the channel conductivity inside here. Channel conductivity. Okay, so you have to remember this. It's pretty much same curve. It's a transistor, but this is bipolar, and this curve is exponential. And the MOS, this curve is voltage square. Okay, and saturation is bipolar. It's follow this exponential, then saturate. The MOS is follow this curve, quadratic equation, then saturate. Okay, so if you draw the load line just like NMOS gate, then it's operate between here to here, depend on the VGS. Okay, so there's no there's an amplification of the voltage because this is VGS, and this is gonna be V out. So in the MOS, amplification of voltage is done by external circuit. But bipolar, there is a built-in amplification of IV, base current, to IC, collector current. There is a beta here. And MOS, there's no such a thing as beta. Okay? So that's the difference between bipolar and MOS transistor. And there are a few other diode we talk about. The one is Zenor diode. Zenor diode is written this way. And Zenor diode characteristic is it's just like a diode. And it's going to go to breakdown, but before it's going to break down, there is a phenomena called the leak current. So Zenor diode, by increasing impurity in the silicon, there is a certain Zenor voltage, and this is not destructive. It's Zenor voltage. It's reached to the Zenor voltage, then the current start flowing very large amount. So VG is fixed and depend on how much current you flow. It's pretty much outside circuit determines. Okay, so this is a Zenor diode. The Zenor diode is like, so the way you use is you use a Zenor diode reverse way. And if Zenor diode is made for, say, 5 volt, this is a 5 volt, then pretty much its voltage become 5 volt fixed, because say this is 12 volt, then 12 minus 5 divided by R is going to be the current here. Okay, so this insists on the 5 because this slope is so sharp. It stay as a 5 volt. The another diode is LED, and LED is light emitting diode. You emit light, and based on this current, the current is converted at a certain efficiency coefficient to the light. So this is just use it as an ordinary diode. For example, you can use this kind of LED and transistor. You can shut off the LED or on, or you can put LED here and transistor to limit the current. So LED draw the current here by transistor, this on or off. So LED turn on and off. Okay. So let's look at the actual transistor. Transistor is most of the case the base in the middle, okay, and collector on the right side and emitter left side. Okay. Now, oh, this is Zener diode. Let's see. Okay, there are certain different arrangement for the power transistor, and power transistor collector is in the middle. The reason is simple. You have a metal base and you have a middle lead. It's bonded. It's not bonded. It's directly connected, and silicon chip is mounted, and this is gonna be bonded by wire, and this is gonna be bonded by wire, and this usually the collector is directly connected to the lead. The reason is this collector is to dissipate heat. For heat dissipation, the collector has to be substrate. So the substrate collector is in the middle, and emitter and base is connected by the bonding wire. Okay, so for the mechanical reason, they have a different arrangement in the lead. Okay. Now, LED usually anode is longer and the cathode is shorter legs. So if you know that, when you look at the LED, you can tell which one to be plus and which one should be connected to the negative side. Okay, let's look at the hand-on electronics. Okay, today we introduce some of parts. The transistor. You see the transistor, 3 legs. One in the middle is the base, and some of them is metallic can, has a little notch here. I wonder if you can see. The notch shows this is the right side, so you look at this way. Metallic can sometimes used for the reliability. This is the diode, and you see the diode has little focus. Okay, the line to indicate the current flow direction. And this is the LED. One side is longer, so this is a power transistor. Power transistor, the pin assignment is different because the middle one is a collector, and that is directly, the metal is connected to this heat sink. This is the heat sink. So what you do is you mount on the PCB and screw it or solder it so that the heat escape from this. The power transistor need a heat dissipation. Okay, so that's about it. From next time, we're going to make some circuit. So I hope you get this kind of the simple tools, so you can try yourself making some electronic circuit. Electronic circuit on the PC board is, this is the USB. The AC comes in and it's converted into USB. There is the inductor, the capacitor, and the simple chip, just one chip, IC chip. This is diode to convert AC to DC, but DC is not clean DC. So this chip, what this chip does is, this chip, the switching AC, the change the frequency and use a filter to flatten and make it a DC voltage, 5 volt. Okay, so this kind of simple circuit we will try later. Okay, so that's the end of second video.